Section 1.4, Introduction to Identities. Let's see the first group of the identities, which is called the reciprocal identity. The first one, cosecant theta, is the reciprocal of the sine theta. An equivalent form, the sine theta is the reciprocal of the cosecant theta as well. The second one, the secant theta, is 1 over cosine theta, or the reciprocal of the cosine theta. Therefore, the cosine theta is also the reciprocal of the secant theta. Number 3, the cotangent theta is the reciprocal of the tangent theta, or 1 over tangent theta. Therefore, the tangent theta is the reciprocal of the cotangent theta. The next group of the identity is called the ratio identity. So the tangent theta is the ratio of the sine theta and the cosine theta. And by definition, the sine theta is divided by y over r. The cosine theta is divided by x over r. When you divide the sine theta by the cosine theta, it's the same as y over r divided by x over r. And then simplify the expression, becomes y over x, the tangent theta. Number 5, the cotangent theta is the ratio of cosine theta and sine theta. The next group of the identity is called Pythagorean identity. It's cosine square theta plus sine square theta equals 1. And this is the most used identity in many math courses. The equivalent form, the cosine theta, can be found by solving the Pythagorean identity, cosine square theta plus sine square theta equals 1. So we subtract sine square both sides. So we have 1 minus sine square theta, and then take the square root, including plus and minus sine. Similar way, the sine theta can be solved by subtracting cosine square both sides. So 1 minus cosine square theta, take the square root, including plus and minus sine. The plus minus sign can be determined depends on which quadrant that the data terminates in. Number 7, another Pythagorean identity is 1 plus tangent square theta equals secant square theta. And number 8, 1 plus cotangent theta equals cosecant square theta. To derive number 7 and number 8, for example, if you start with number 6, or cosine square theta plus sine square theta equals 1. Divide this identity by cosine squared. Cosine square over cosine square returns 1. Sine square over cosine square is tangent square. Equals 1 over cosine squared, or the reciprocal of the cosine squared is the secant squared. That will give you number 7. Another case, use number 6 as well. So cosine square theta plus sine square theta equals 1. In this time, we are going to divide all terms by sine squared, theta. The cosine squared over sine squared theta is the cotangent theta, cotangent square theta. Sine squared over sine squared is 1. 1 over sine squared, or the cosecant squared, which is the identity number 8. So you can derive number 7 and number 8 using number 6, which is the one that you're going to use the most, or the cosine square theta plus sine square theta equals 1. Let's look at the examples. Let sine theta equals 3 over 5. The cosine theta is negative 4 over 5. Find the following. We are going to find the cosecant theta. The cosecant theta, we know that it is the reciprocal of the sine. So 1 over sine theta. Since sine theta is 3 over 5, so cosecant will be 5 over 3. The tangent theta is the ratio of sine theta and the cosine theta. In this case, the sine theta is 3 over 5 divided by the cosine theta, which is negative 4 over 5. When you divide the quantity, it's the same as multiplied by the reciprocal. Therefore, the tangent theta is negative 3 over 4. The cotangent theta is the reciprocal of the tangent. From part B, the tangent is negative 3 over 4. Therefore, the cotangent theta is negative 4 over 3. For number 2, find sine theta if cosine theta is 5 over 13 and theta located in quadrant number 4. In quadrant number 4, we know sine is less than 0. From the order pair located in quadrant 4, x positive, y negative, and the sine theta is divided by y over r. R is always positive, therefore y will be negative in quadrant 4. From given value cosine theta as 5 over 13, and using the Pythagorean identity, which is sine squared theta plus cosine squared theta equals 1. Therefore, the sine squared theta it should be plus or minus square root of 1 minus cosine squared theta. But we keep negative sign because it's in quadrant 4. So sine theta is negative square root of 1 minus the quantity 5 over 13 squared. Simplify the numbers to get negative 12 over 13.